Awesome. We're doing great. Or you're doing great. Well, actually, technically, I'm doing great. Okay. Last thing, discriminant. Okay, maybe you're already seeing something interesting here with the quadratic formula. See this b squared minus 4ac thing? That's called the discriminant. And it's really important in the quadratic formula because if the discriminant is evaluated using order of operations and it's positive, right? If that's positive, if we're talking about a quadratic function, so let me make sure you guys understand the distinction. Here we go. Let's make sure you understand the distinction. A quadratic function. Wait, that was supposed to be an A. Let's try that again. Quadratic function. Functions have inputs and outputs. So that would be y, well, I'll just do it this way. Ax squared plus bx plus c equals 0. Or sorry, equals y. Sorry, output, it's a function. So what's going on here? Input for x, output for y. This is the standard form of a quadratic function. It produces a parabola. Well, the quadratic equation, which is what you can use the quadratic formula on, looks a lot like it, but instead of y, it's 0, right? So this is the thing, the quadratic equation, this is what you can use the quadratic formula on. It assumes that if you had a quadratic function to begin with, it assumes that y is 0. And if y is 0, these are the x-intercepts. So if the discriminant b squared minus 4ac is greater than 0, then you're going to get both a positive square root and a negative square root. So you're going to get two solutions or two x-intercepts. Two real solutions, two x-intercepts. Now, if b squared minus 4ac is equal to 0, now when you take the square root of 0, you don't get a positive or a negative. You just get one solution. It's just 0. So it's negative b plus or minus 0. It doesn't matter. You're going to get the same value. Divided by 2a, that's only one real solution and one x-intercept. It's also possible that when you evaluate b squared minus 4ac, you get a negative number. Now, if it's negative, you can't take the square root and get a real solution. So there's no real solutions, and therefore there are no x-intercepts. So this discriminant can tell us kind of what our graph's going to look like. Is the parabola going to have two x-intercepts? Is it going to have just one, or is it going to have none? So now let's take a look at an example. Determine the number of real solutions of x squared plus 8x minus 3 equals 0. Now I could do all of the quadratic formula and like solve it, figure out where the x-intercepts are, or I can just use the discriminant. The discriminant right here, which is the b squared minus 4ac thing. So I do still need to know what a is. A is equal to 1 in front of, that's the coefficient in front of x squared. B is equal to positive 8, the coefficient in front of x. And c is equal to negative 3. Now I can use the b squared minus 4ac. Well, b squared, that's 8 squared, which is 64, minus 4 times a times c. And we're going to compare this to 0. So negative times a negative is a positive. And really, you've already answered the question, right? Negative times a negative is positive. So we know we're going to get a positive number here. But we'll keep going anyway. 4 times 1 is 4, times 3 is 12. So that's 76. And 76 is greater than 0. So there are two real solutions. Two real solutions. Ayabuka. Okay. Now the next one. You're probably like, I already get it. already get it. I'm just gonna go into the homework now. I already get it. Well, I'm gonna keep on going, okay? I'm gonna do it for you. I'm gonna keep on going for you. Determine the number of real solutions of 9x squared plus 1 equals 6x. Well, look at that. That right there is not a quadratic equation. You're gonna have to write that first in ax squared plus bx plus c form equals 0 form. So I'm gonna subtract 6x from both sides first, and I get 9x squared minus 6x plus 1 equals 0. This is a quadratic equation, and now I can use my discriminant. So a is equal to 9, or b is equal to -6, and c is equal to 1. So b squared minus 4ac, that's -6 squared, which is 36, minus 4 times a times c. Now it's going to be 4 times 9 is 36, times 1 is 36. That's 36 minus 36. That's 0. And 0 is equal to 0. 0 is equal to 0. So that's, I should have said this last time, but if this is equal to 0, then there's one real solution, one x-intercept. The last one, 76, is greater than 0, so the value of the discriminant was greater than 0, so that's why there's two solutions. Let's just say 1, whoa, that's a 1. It's a special one because it doesn't even look like a 1. One real solution. Okay, next one. Find the number, this is slowly going, the number of x-intercepts of the graph. This is a function now because it's an output. Y equals 2x squared plus 3x plus 9. Of course, if it's x-intercepts we're talking about, we're going to make y equal to 0. And without having to graph it or anything like that, we can already tell how many x-intercepts there will be by doing this discriminant business. So a is equal to 2 in this case, b is equal to 3, and c is equal to 9. There we go. Okay, so b squared, I'm going to do that over here this time, save myself some space, minus 4 times a times c. Okay, so 4 times 2 is 8. 8 times 9 is 72. I have 9 minus 72. Uh-oh, this is going to be a negative number. And if it's negative, it's less than 0. There are no x-intercepts because there are no real solutions. There are no x-intercepts. Woo! So now that if you made it to the end of the video, the first person to write "purple monkey dishwasher" in the comments on Google Classroom, I will do a shout out to you in the next video because you listened all the way through. Thank you, whoever you are, wherever you are, and whatever you're doing. Wait, you're doing algebra, which makes sense. Have a very nice day, everybody.